Welcome to my presentation. My name is Tim, and I am within Twikit responsible for the medical department. And within medical, you can imagine that the OMP business is quite a big chunk of it. So today I'd like to introduce you to a customer case of ActivArmor, which is in the OMP environment. And the title of the presentation is How ActivArmor Revolutionized Costs through 3D printing and design automation. Now, as design automation is the core of what Twikit business is about, you can imagine also that I will deep dive a bit more into that. First of all, let's start with the customer itself. So ActivArmor is a US-based company, and they wanted to revolutionize casts. And basically, the idea is if you have a fractured limb, of course, you're in pain, but you're also in a lot of frustration because probably you'll have to wear a cast for like 6 or even more weeks, which is quite annoying. So looking at the problem of this traditional casts, first of all, it's not water resistant, so it's very uncomfortable to take a shower, for example. Secondly, it gives a lot of transpiration, and the transpiration gives you a lot of itchiness. So we all remember us poking with a ruler into the cast to make it go away. And especially since the pandemic, there's a lot of attention for the germs, and it's a breeding ground for germs. So that's something we should take care of. Last but not least, wearing a traditional cast is not cool. It's not cool because it's quite warm, but it's also not cool to wear as a statement, of course. So as a sum up what ActivArmor wanted to do, they wanted to have a waterproof cast, which is breathable, which is sanitizable, and which is pretty cool to wear that people would actually like. So they did their research and they said, okay, how can we implement or find a solution to bring this to the market? And they said, okay, 3D printing is the way to go. As you might imagine, it gives a lot of possibilities. And they said, okay, we have 10 products in mind. So they started designing 10 different CAD files to deliver. And they opted for the FDM technology using a Fusion 3 printing because it's easy to operate, it's easy to work with, and especially it's easy to implement in a decentralized production environment. You see the word but, that means that there is a very big disadvantage about this because it's very difficult to scale. And why is this? Because each product needs to be fitting to a patient scan, and a patient scan needs a CAD optimization by a CAD engineer, and this takes up to 1 to 2 hours to make sure that the cast is fitting a patient arm. So you can imagine for a company like ActivArmor, it's a really blocking factor for scaling, and that's why they needed to have design automation. Referring in the beginning of the presentation, that is why Twikit comes in, because design automation is the core of what we do. We make sure you can do mass customization by using design automation. Now, looking at the orthotics workflow that we developed, that means that you have a couple of stages. Specifically for ActivArmor, you would start with a scan. Each scan is unique for each patient. You do the import of the scan. We're open to any device or any scanning technology. And then you go to the user flow where you do the design automation, where you do the validation of the product, and of course the parameterization. And what comes out as a result of this flow is a production ready file with a unique order ID. So this can be briefed directly to the manufacturing systems. In this case, it's an FDM technology with a unique ID for traceability reasons to have a quality reassurance system. Now, if you bring this to the greater scale, that's of course a bigger picture, because Twikit is not only working for the OMP business, but in general, we are a web-based system, so it's easily accessible all over the world. The only thing you need is an internet connection. And the idea is that you have end customers who are using the customizer all over the world. They give a product briefing. They make all the adaptations within the product. Twikit will connect everything together, make sure that the customization is ready to be produced. And in the end, we will brief the digital manufacturing systems, which can be local, which can be centralized in any other way. So as a takeaway, what Twikit really is about, we enable mass customization for digital manufacturing through design automation. That is really key of what we do. I'll just briefly give you a video, a screenshot capturing of how the actual workflow looks like for ActivArmor. So this is a portfolio overview which a clinician can actually access within his clinic. He chooses the right product and he selects or creates a new patient. And the next step, he will upload a scan. Again, as mentioned before, we use any scan technology. As long as it is an STL or an OBJ file, we can import it and we can start the actual workflow of the design process. So the first step is to do some scan alignment. You can replace or reposition the scan. You can move it around, you can rotate it in a very easy to use interface, which can be discussed with you as a customer. So it's all tailor-made and all up to your wish list that we can adapt it. And as a next step, we could do some scan cleaning. So in this case, it's just to show you because the scan is quite nice, but if there are parts of the scan that you don't need and that might pollute the actual result of the scan, you can cut away simply by using this tool. You can cut away the bad parts and you can continue with a perfectly suitable scan. So this is what you have as a result here. And this is the scan we will use to do the design automation, which is showing in the next step. So the design automation itself, remember I told you it takes a couple of hours to do it in a traditional way. Here, it's just a couple of reference points that you need to set as a flow to, first of all, set the outer boundaries of the product, but also to attach some anatomical reference points like an ulna or like other important elements of the scan to make sure that there is no interfering system or interfering points. Last but not least, you have a parametric design, so you have some parametrical options to adapt and change the product, the length of the brace, the diameter of the hole for the ulna, for example. This is things you can also easily do within the interface. The last step now, once all the parameterization is done, you go to the final product, which is actually the product that you can see here, which is ActivArmor's wrist cock-up, and it's 100% fit to the scan at a very, very small tolerance, less than a millimeter, which is quite impressive. So last but not least, you have the overview here. You can order the product and you'll come directly into an order service interface where you have again the order ID. For traceability purposes, you can have all the details. You can go backwards and find everything in case something went wrong. And you have also all the digital assets at your disposal, which is ready for production. And it can be either done manually or it can also be using an API connection, connecting directly to an MES system to brief the factory to produce directly. So to conclude on the ActivArmor case itself, what we did together with them is we made, first of all, a better product, which is much more comfortable and easy to use for a customer as a patient. The fact that we have 3D printing technology based on a very tight design automation system means you have a consistency in quality, which is not the case in traditional casts. And you have, of course, a huge increase in efficiency. The processing time is very limited. As you saw in the little video, it takes you up to 3 or 5 minutes, which is a huge advantage compared to the other traditional way of working or the manual CAD work. And of course, this enabled ActivArmor to basically be able to scale, which is enhancing their business quite a bit. Thank you for listening. And if you have any questions, please come over and have a chat.